Good day, sleepyheads. We are continuing PO46, working with function tables, and ultimately we're going to get some word type problems today. So we did the first three together, just basically making a function table where you get to pick the input. You pick what we're plugging in for x, and we see what we get for y. That'd be the output, right? So just continuing this here, y equals x squared minus 10. We're going to make our xy table. And actually, this time I'm going to put a little bit something extra in the middle, just so I got some more space here. Give me a number, 4x, whatever you want. Who didn't I pick on yesterday? Nolan, I didn't pick on you because you weren't here.
Yeah.
Give me a value for x.
Like 10.
Pick one.
10.
10, excellent. So in x squared minus 10, if we're making x 10, basically what we're doing is we're replacing the x variable with our choice with 10 in the equation. Nothing else changes, okay? Nothing else changes. And what is 10 squared minus 10?
90.
90. 10 squared is 100, right? Not 20. It's not 10 times 2. 10 times 10 is 100. Then subtract 10, and we get 90 as our output, right? Pick another number. Lily. 6. This time we're plugging 6 in for x, so nothing else changes. We're still squaring it, still subtracting 10, only with a different value for x here, okay? And what is 6 squared minus 10?
26.
26. 6 squared is 36, minus 10, that gives us 26. Tristan.
3.
3. This time plugging in 3 for x. Again, nothing else changes, only the value that we're testing, only that input, x. 3 squared minus 10 gives us what? Gregory?
-1.
-1, right? 3 squared is 9. 9 minus 10 is -1. And we have room for a fourth one today. Aiden.
4.
4. 4 squared minus 10 is what?
6.
Yeah, 6. 16 minus 10 is 6. And who remembers why we care about these x and y values? What do they represent? Coordinates, excellent, right? They are these solutions to the equation to where eventually when we get to graphing these, we essentially have 4 ordered pairs we can put on the coordinate plane. 1090, you don't have to write this down necessarily, but 1090, 626, 3, -1, and 4, 6 are all ordered pairs, all coordinates on this line. Landing question or stretching? Stretching, very good, all right? The last one, y equals 1/4 x plus 7. Now, I'm going to ask for values again, but I'm going to ask for smart values, okay? The beauty of this is you get to pick what value you want x to be, but in a situation like this, you can either pick a smart value, I'm not going to call it a dumb value, but you can pick a challenging value, okay? So what would a smart value be for x to plug into this equation that we could solve? Anthony,
4.
why is 4 smart?
Because like 1/4 times 4 is 1.
Yeah, okay. We're taking whatever value that we pick times 1/4, and does 1/4 of 4 work out evenly? Yeah, 1/4 of 4 is 1, right? And then 1 plus 7, we would get a y value of 8. Give me another smart value here. Kristen?
2.
2, I would call that a challenging value. Because if we plug in 2, we're taking 1/4 of 2. That doesn't work out quite as evenly as 1/4 of 8. Could we pick 2? Yes. Will it work? Yes. But I want to stick with what we're going to call smart values here, rather than the challenging ones.
8.
8 would be smart. Why? What's 1/4 of 8?
1/4.
Cut a pizza into 8 slices. You take 1/4 of them. How many slices did you take?
2.
2, right? 1/4 of 8 is 2 because 2 goes into 8 4 times, right? So 1/4 of 8 is 2. 2 plus 7 equals 9. Give me another smart value here. We can easily find 1/4 of it.
12.
12. 12 is smart. Because 1/4 of 12, you have 12 things, you take a fourth of them. How many things did you take? Or another way to look at this, what goes into 12 4 times?
3.
3 does, right? A fourth of 12 is 3, and then plus 7 equals 10, okay? So the reason why those are smart values, right, is because they're all multiples of 4. And if we're taking a fourth of that number, we want that number, what we're picking, to be a multiple of 4, so it works out evenly, okay? It works out evenly. Give me a couple different ways. Well, we actually already kind of talked about it. Like 1/4 of 12. I said, you know, if you have 12 things, you take a fourth of them. How many things did you take? How many times does 4 go into 12? You can also do this by just multiplying fractions. How many multiply fractions, William?
You do 1 times 12.
Right. We go straight across. Right? 1 times 12 is 12. 4 times 1 is 4. What's 12 divided by 4?
3.
3. Right? Same thing we got over here. 3 plus 7 equals 10. So don't be afraid of fractions. We've worked with them enough to where you should have some tools for how to calculate with them. And like I said, the beauty of this is you get to pick what these values are. Right? So make them smart. Make them smart. Okay, here's the application of this. This first example here, it says, after a week of timing yourself during your morning run, you discover you can run 4 miles per hour. Okay? Let H represent the number of hours you run, and D represent the distance that you run. I'm asking for what is the input, what is the output, and then to write an equation that relates the input to the output. Now remember, what does the input do? It was on our homework check. We defined it. What is the input?
What you put into the equation.
It's what you put into the equation. It's what's being tested. Okay? So if you look at letter D, and the reason why I'm pointing this out is because this is what it's going to be like on your test as well. Letter D says, create a function table that will show how far you will run in 3 hours, in 8 hours, in 12 hours, in 20 hours. What are we testing? Are we testing the hours, or are we testing the distance?
Distance.
We're testing the hours, right? How far will it be in this length of time? How about this length of time? How about this? How about this? Right? We're inputting the hours into the equation. That's the variable I'm giving you, so that what we get out of it is how far we run. So when looking at what's the input, what is the output, a great place to check is this fourth question here. Because what's being tested is going to be the input. We are testing the hours. And then what we get out of this is going to be how far we run, the distance. Okay? Now, if you run 4 miles per hour, what equation represents that? Distance equals what? How would you calculate how far you run if your rate is 4 miles per hour? Well, if you run for 1 hour, how far did you go?
4 miles.
4 miles, right? 4 miles per hour. You run for 1 hour, you went 4 miles. What about 2 hours?
8 miles.
How about 3 hours? Well, 4 hours. Well, 5 hours. What are you doing to get to the answer? When I say how far do you run after 2 hours, what did you do to get to 8?
Going up by 4.
Going up by 4. When I said 5 hours, what did you do to get to 20? Going up by 4. So let's skip now. What if I said 10 hours? Who said 40? How'd you get there? Right. If you're going 4 miles per hour, you are taking whatever the hours are and multiplying by 4. Your rule for this table, your equation here is the distance equals 4 times the number of hours that you run. Remember that word per is a sneaky little way to show that we are multiplying, right? 4 miles per hour, 4 times h. Okay? Questions on how we set that up? This is usually the hardest part for folks here, is coming up with the input, the output, and then what the equation is. But I gave you a hint for the input and the output. Look at that 4th question there. That's going to tell you what's being tested, right? And then coming with what that equation is, well, just kind of play with the numbers a little bit, okay? I'm going to have you create the function table on your own, because I want to do another example of ABC here. I think this is the hardest part, okay? It says you pick up a summer job, and I started working when I was 14 years old. Spring break, 8th grade year. I was looking forward to having a week off, sleeping in, doing whatever I wanted. No. 6 in the morning, Dad comes down. Hey, I got you a job. Get out of bed. Thanks, Dad. Thanks so much. First job. 14 years old. Pay the base salary of $500 and an additional $9 per hour worked. Okay? So a base salary would be kind of like, for you sports folks, like a signing bonus. Okay? You get that just for showing up, right? But then you also earn $9 per hour that you work. Let H represent the number of hours and M represent the money that you earn. Again, what is the input, what is the output, and then what's that equation that relates the two things, okay? Take a look at the other information that we have here. What is the input, what is the output? What are we testing? What's the result? Hayden?
You're testing the hours you work, and then the output is the money.
Yeah. Okay. Again, you can look at this as for a hint here. It says create a function table to show how much you will earn after working an hour a day, which is 8 hours, a week, 5 days, a month, which is 4 weeks. Right. We are testing the hours worked. We're plugging that into the equation, and what we're getting out of it is the money that we earn. Okay. Now for the equation, the money that we earn is equal to what? What's the equation that we're going to be plugging in these values into here to make our function table? Yeah?
How many hours you work?
And then do what with that? Like if you work for 2 hours, how much money will you make? All right, what's the equation that we're plugging that into to get this answer? Landon?
9 times H.
That's close. 9 times H, right? That's the $9 per hour, but don't forget about that signing bonus. So 9H is part of it, right? Because it's $9 per hour, but you also earned that $500. And you only get that $500 once, right? It's a base salary of $500. You get that once, okay? So that's going to be our constant. That's the signing bonus. You only get it once, right? And then you earn more money the more time you put in. So this one's a little bit longer than our first equation because it's got that extra constant there, right? But if you work for 2 hours, 9 times 2, you get 18 plus the $500, $518 total, right? Work for 10 hours, 9 times 10, 90, plus the $500, $590 total, okay? This function table involves a little bit of conversion as well. Notice it starts with working for 1 hour. So I'll kind of get you started here. In our function table, let's do H for hours and M for money there, okay? The first number that you're testing is 1 hour, 1 single hour, right? And then the next one is a day, 8 hours. So our second one that we're testing here is 8 for H. But then I want you to figure out how much money you'll earn after a week, which is 5 days. So what number are we going to be plugging into our equation if we want to know how much money we'll earn after 5 days, with each day being 8 hours. Do we plug in 5? Gregory? Multiply what by 9?
8.
Well, we're going to do that to figure out how much money we earn in a day, which is 8 hours. Right? We're plugging that 8 into 9 eighths plus 500. That's our rule for the table. But if I want to know how much you make after a week, which is 5 days of working, what number are you going to be plugging into the equation? Why 40? Right. Since our equation is in the unit of hours, if I ask for 5 days, well, 5 days is equal to 40 hours. Because each day is 8 hours. Right? So you're not going to be plugging in 5 here, you're going to be plugging in 40. That's how many hours you work. Okay? This is real life application stuff. When you do get out there and you start to have a job and maybe you have a car, you have to pay for your own gas and maybe some other expenses too, right? You've got to kind of budget out a little bit. Say, can I afford this? If this is how many hours I work in a week, that's how much money I'm going to have, what can I do with that money? Okay? And then lastly, a month, which is 4 weeks. What number are you plugging in to our function here? I want to know how much money you make after 4 weeks. Each week is 5 days. Each day is 8 hours. What number are we plugging in? Landon?
160.
How did you get 160?
40 times 4.
Right. If 1 week represents 40 hours, 4 weeks is going to represent 160 hours. Right? 4 weeks, we get that by taking 40 times 4. Because 40 hours in 1 week, 160 hours in 4. It's almost like we're doing a proportion, isn't it? Imagine that. We've done those before. Right? So those are the values that you're plugging into your function table there. Right? In the next 10 minutes, I want you to get together in either groups of 1, 2, or even 3 and finish these first 2. Okay? Don't go on to the next page yet. Finish these first 2 in groups. We'll talk about the answers. Questions on what I want you to do? Okay, very well.